Chapter 2, Section 2.4, Complex Numbers. Here are our section objectives. And we'll start with the imaginary unit I. The imaginary unit I is defined as I equals square root of -1. Remember, when you're doing square roots, let's say you're doing square root of 4. You're looking for two numbers that when you multiply them, give you 4, and they have to be the same. So the square roots of 4 would be 2, because 2 times 2 is 4. And there's another one, -2 times -2 is also 4. So square root of 4 would be 2 and -2, because both of them, if you multiply by itself, give you that 4. When you're looking for two numbers that multiply to be -1, there are not two numbers that are the same, that if you multiply them together, you'd get a negative. And so we call that I because it's imaginary, because it doesn't exist in the real numbers. So it's a complex number because it is, it's imaginary. Complex can be an imaginary and a real combined. So when we see standard form of a complex number, we may have a real part to it, and we'll have an imaginary part, and we're adding them together. So this says, for instance, the standard form of this complex number, we could reduce this a little bit. So -5 is real. Square root of a negative will be imaginary. Square root of 9 is 3. Square root of negative, like a -1, would be I. So the square root of the 9 part is the 3. The square root of the negative part is the I. So the standard form, the simplified way to write that would be the real part first, -5. The imaginary part would be plus 3I. If you have, this is just the work for it. So it kind of shows how the 9, positive 9, breaks down into 3 squared, and the negative is multiplied, -1, and then it breaks down 3I. Like I said, complex number can have a real and an imaginary part added together. What you can do with complex numbers is add or subtract, multiply them. So, we'll go through and kind of see how that looks like when you're doing some examples. So here, if you have a complex number plus another complex number, you may remove the parentheses if there's no coefficients and no exponents. So I did that. And then you would add the real parts. 4 plus 1 is 5. And then you add the imaginary parts. 7i plus -6i would be I. So you add the real parts, add the imaginary parts. Here's another example. Remove the parentheses. 1 plus 3 is 4. And 2i and -2i would be 0. So that answer would just be 4. Here it is typed out. Now you can add, multiple complex numbers together. I will say when you're subtracting, it's the typical rule, distribution rule, where you will have to distribute the minus. So this would be 3i plus 2 minus 3i minus 2 minus 5i. So when you add your reals, 2 and -2, those would cancel out. Then you'd add your imaginaries. So 3i and -3i, those cancel, or you'd just be left with -5i. Here I'd have to distribute my negative, so this would be 3 plus 2i plus 4 minus I minus 7 minus I, and then you'd go through and add your reals. 3 plus 4 is 7 minus 7, that's 0, so those cancel out. 2i, -I, those cancel out too, so my answer to that would just be 0. There's typed. You can also multiply real number times complex, complex times complex, multiple things you can do. So we'll start with part A and kind of walk you through how to do these. Part A, I can distribute that 4 to get -8 plus 12i. So you are able to multiply a real times a complex. B, you have a complex times a complex. Since they're both in binomial form, I'm going to multiply these by distributing everything or foiling. So 4 times 2 is 8, and then 6i minus 4i minus 3i squared. Now, complex numbers do not have I squared terms in them, so I will have to simplify that out. I'm going to go back, kind of way back up at the beginning. Since I is square root of negative 1, if I square both sides, I squared is square root of negative 1 squared, which is negative 1. So if I ever have an I squared in an expression, I can sub it out for negative 1. So here I have 8, combine both those, plus 2i. Negative 3 times negative 1 would be plus 3. So if I add my reals, I have 11 plus 2i. Next up, part C, I am now again multiplying two complex numbers, but these are special complex numbers because they are almost identical. They are 3 plus 2i and 3 minus 2i. Those are conjugates of each other. Conjugates mean you have the same first number and last number, and the only thing that's different is the sign in the middle. And I'm going to show you what happens when you multiply by conjugates, or when you multiply conjugates together. So 3 times 3 is 9, minus 6i plus 6i minus 4i squared. Talked about this before. I squared can be subbed out for negative 1. So if I combine like terms, I have negative 6i, positive 6i cancels. I'd end up with 9 plus 4 is 13. So I wanted to show you what happened when you multiply by conjugates. You can see it turned into a real number, and that will always happen. If you multiply two complex numbers together that are conjugates, they turn into a real number. So it's a way to make it real. Last one is 3 plus 2i squared. When you multiply something by itself, 3 plus 2i times 3 plus 2i, these are not conjugates of each other, so it won't turn real, but I still can foil, like I can distribute and I can multiply those. So 9 plus 6i plus 6i plus 4i squared. I squared is negative 1. So here if I combine my real numbers, I'd get 9 plus negative 4, so that'd be 5. If I combine my imaginary numbers, I get 12i. All right, there they are typed. I talked about complex conjugates, and they are identical, besides your middle term is opposite. This says write in standard form. Standard form would be not having a fraction, with an imaginary number on the bottom. So if we want to do that, what we can do is take this start, and we can multiply the top and the bottom by the conjugate of the bottom. The reason I want to do that is I'm really interested in not having an imaginary or complex number on the bottom. And so I know that if I multiply by the conjugate, I can get a real number on the bottom. So when I do that and foil the top ends up being 8. I'll use a different color. 8 plus 4i plus 12i plus 6i squared. I squared is negative 1. So I'll work on that in a second. On the bottom, my first is 16. My outsides and insides will cancel like I saw before. And my insides are minus 4i squared. I squared is negative 1. So I'm going to continue to work. I'll start with working on the bottom. 16 minus 4 times negative 1 would be 16 plus 4. So on the bottom, I got 20. On the top, I have 8 plus negative 6. So I have 2. My imaginaries are plus 16i. So if I want to kind of write this out in standard form, which would be like real plus imaginary, I'm going to split up this fraction, 2 over 20 plus 16i over 20. This is my real part, this is my imaginary part, and I'll reduce them both. This is 1/10 plus 4/5 I. Here it is typed. Another place that complex solutions come up often is in the quadratic formula, because the quadratic formula has a square root. And so here, the quadratic formula is something you learned earlier in algebra. Here is a quadratic equation set equal to 0. You can always factor these if they're factorable. If they're not, you reach to the quadratic formula, and here is all the numbers typed in. Sometimes, if you look at the determinant, it might be negative. So I took the head start, and now I'll take over on my own. So x equals 2 plus or minus, this is 4 minus 60, which would be negative 56. So when you have a negative as your, square root number, that, would be an imaginary number. So here's how I'm going to deal with that. I'm going to say 2 over 6 plus or minus square root of negative 56 over 6, and I can deal with both of these separate, so I just kind of split them up. So here I'd have 1/3, and my square root of 56, I want to first split that up into square root of negative 1, and then if I can think of two numbers where one of them is a perfect square, I could reduce this a little bit, and I'm thinking 4 and 14. So I took negative 56 and I split it into 3 radicals. So I still have my 1/3 out in front. Square root of 4 is 2. Square root of 14, I cannot break down anymore. And square root of negative 1 is I. So breaking that down, it leads me to here. Now 2/6 can be reduced to 1/3. So my very final answer would be my 1/3 out in front plus or minus square root of 14 over 3i.